Now let's consider the following example. A farmer has 1,888 feet of fencing available to enclose a rectangular area bordering a river. Now, no fencing is required along the river. Let X represent the length of one side of the rectangular enclosure that is perpendicular to the river. Create a function AX that describes the total area of the rectangular enclosure as a function of X. Now, X here is the length of the rectangular enclosure that is perpendicular to the river. So to do this, let us first draw the figure, okay, to illustrate our problem. For instance, this is your river. And then you have the rectangular enclosure here. It says here that you use X to represent the length of the rectangular enclosure that is perpendicular to the river. So we're referring to this side here. Now, if this is the side X, that means this side here is also X because it's a rectangle. Now, to compute for this side here, we will use the formula for the perimeter. Now, it is given that the farmer has 1,888 feet of fencing available to enclose this rectangular area here bordering the river. So that means that the total length of this side and this side and this side should total to 1,888. So you have 1,888 is equal to X and X, and this side here. Maybe we'll call this side here Y. So we have X plus X means 2X. So 2X plus Y. Now we want to solve for this Y in terms of X. So from the equation here, we can actually find the expression for Y by transposing this 2X to the other side of the equation. So you have 1,888 minus 2X is equal to Y. So that means that we can replace the Y here by 1,888 minus 2X. So that's this is actually the Y. So that's the side. Now, to find A of X, so now we want to find our area function. So if you recall, the area of a rectangle is just length times width. So that means you're just going to multiply the sides. So we have this side here times this side. So that means we have 1,888 minus 2X times X. That's length times width. And then we have 1,888x minus 2x squared. That is your area. Or you can write this as negative 2x squared plus 1,888x. Next, find the dimension that will maximize the area. So we want to maximize our area here. Notice that the area is a quadratic function and the coefficient of the leading term, A, is negative. That means that this one has a graph of a parabola that opens downward. That means that the vertex of the parabola is a maximum. So in other words, we get the to get the maximum area, we get the vertex of the parabola. So we get first the x coordinate, and that is given by the formula negative b over 2a. So referring to this equation here, b is 1,188. So negative 1,188 over 2a. 2 times our a is negative 2. Now simplifying this, negative 1,888 divided by negative 4 is equal to positive 472. That is your x, and x is actually the width of the rectangle here. So that means the width is 472. Now the length of the parabola is 1,888 minus 2 times 472. So just plug that in. And this gives you 944. These are the dimensions of the fence that will maximize the area. Now, to find the maximum area, these are already your dimensions. So the area, we know that that is just length times width. So that means you just multiply 944 times 472. Now you get 445,568. So that means 445,568 is the area, square feet.